Sorry for the inconvenience. Internet is one of the most used utility these days. Sometimes we do get into this trouble of slow speed. But thankfully, we are back again. Let's start. So the focus of Umar, can you give me the recording permission for the meeting, please? Okay. Now, the focus of this session is on using non-parametric alternatives to independent sample t-test and one-way ANOVA. Now, what if you have got a data and the data is non-normal, or there are distribution issues in your data? Or what if the data is in ordinal scale? So, or the variable that you want to evaluate is in ordinal scale. So what are the alternatives for testing such data? Now let's assume we've got this data about, let's say, this is a one variable, perceived contextual barriers to entrepreneurial orientation. So I've already created or transformed this variable into a single measure, a PCB, and I want to evaluate whether PCB differs between male and female respondents, or their perception of contextual barriers actually differs between male and female respondents. But the problem is that I've identified that the PCB variable is non-normal. So how would I check for differences between female if I've got data which is non-normal? So a simple and easy way to do this is you use non-parametric tests. So go to analyze non-parametric tests, and in the legacy dialogues you use two independent samples because you've got two independent samples. One is male, the other is female. So you just press this two independent samples and you select your categorical variable in which you want to evaluate the differences. In this case, we want to evaluate whether perceived contextual barriers or the perception about the contextual barriers actually differs between male and female respondents. So you select your categorical variable, press this arrow button right before this grouping variable, and you define your groups. In this case, we have got two groups identified by 1 and 2. You press continue, and I'm interested in perceived contextual barriers. So this is what I want to test. So you can test multiple variables and then Mann-Whitney U test is selected. So you just press OK. And here are the results. So if you see, there is mean rank or sum of ranks. There is n, and then there are the two categorical variables. And what we are interested in is this test statistics. And in test statistics, we are interested in significance. So if we look at this significance, this is less than 0.05. So this means that there are significant differences in the perception about contextual barriers between male and female respondents. So the way that male employees think about contextual barriers is different in comparison to females. Now, if you see that the mean rank, it's 282 and the mean rank for females is 180. Now this means that the perception about contextual barriers is high. That this means that male perceive that the contextual barriers are higher in comparison to females. So a higher mean rank in this case means that according to males, in their perception, the contextual barriers are significantly higher in comparison to females. So females think that the contextual barriers are not that high. So this is one example that one can use. Let me run this test with another variable so it becomes more clear to our audience. Now, non-parametric test, legacy dialogues, two independent samples. Let's say I change this variables to variable 2, and let's see if I'm interested in entrepreneurial orientation. Does entrepreneurial orientation, or sorry, intentions differ in male and female respondents? So we press OK, and the entrepreneurial orientation is higher in male in comparison to females. So male have got higher entrepreneurial orientation in comparison to female, because the mean rank for male is higher in comparison to females. So what if we want to interpret, and is this difference significant? Yes, this difference is significant because the significance value is less than 0.05. Now, how would you interpret this results? Just copy these two tables, and let's get to our Word document. And if we can just first copy. Okay, let's first propose our hypothesis that we want to test. So H1 is there is a significant difference in entrepreneurial intentions between male and female respondents. Now we've got the results. Let's interpret and report the results of this hypothesis. Now, hello, yes. Hello. Okay,
guys,
let's get back.
Switch off your.
Turn off your mics, please. Thank you. Okay, now let's interpret this. This is the So here is your Mann-Whitney U statistic. So you just put it in, and then your p-value is less than 0.001. So if the significance value is 0.000, you just write p is less than 0.001. Otherwise, you just write the p-value as is. P is equal to, say, if it was 0.10, you would have written p is equal to 0.010. You only use the lesser sign when it is 0.000. Now, this is how you actually interpret the results for your Mann-Whitney U test. Now, how do you report? You just can't just put these tables in your document. This is against formatting. So what you can do is, let's do this. So you first remove this column. You make sure that all borders are highlighted. Let's say I'm going to layout, draw table. Let me add another column. Let me add this one in, this one here, and the significance rate is 1000. And now we don't need this table, so we remove this table and let's format it a bit. Okay, and then we just select home. Sorry, I'm a little fussy about this formatting. So, and obviously it's good that one should learn about these formatting as well. So, and again, you can select the table, no border, select the bottom border, select the top border, and then the first row, just select the bottom border. Now this is how you can, oh sorry, might have made a mistake here. So you select the top border. Now this is how you report Mann-Whitney U test in proper. Now this is done for Mann-Whitney U test. If you've got any questions, please ask. Hello. Yes, any questions? No questions. Okay. Okay, let's go to our final topic. No, sorry. We were to do regression as well. Okay, let's do regression in the end. But now let's keep the theme of differentiation, and let's focus on our next test, which is Kruskal Wallis H test. Now, in this particular example that we just did, in this example, we had two groups. So I wanted to evaluate whether entrepreneurial intentions differ between male and female. What if I've got more than two groups? So you cannot use Mann-Whitney U test. What if the data is not normally distributed or data is in ordinal scale or at ordinal level? And I'm interested in identifying or evaluating whether a particular variable differs between more than two groups. And in this case, let's say our groups are maybe age. So I've divided age into young, middle-aged, and old. And I want to assess whether entrepreneurial intentions differ between young, middle-aged, and old people or not. So how would I conduct a test that evaluates these differences between these three categories? Now, in order to do this, you press Analyze, same non-parametric tests, Legacy Dialog, and K independent samples. So you press K independent samples. And I'm interested in age. Define the range. The minimum is 1, the maximum is 3. And I'm interested in entrepreneurial intentions. So you select this and Kruskal Wallis H test, and then just press OK. It will give you the results. Yes, please.
Minimum and maximum range is constant, 1 and 3.
Yeah, because there are three groups. If you see the dialog box on your screen, there are three groups: young, middle-aged, and old. So 1 signifies young and 3 signifies old. So that's why the minimum was 1 and maximum was 3. So it's the numeric representation that you have given to your groups. That's why in our previous session, we mentioned that always try to represent your data in the form of numbers. So this helps you do your analysis. So in this case, I represented young with 1, middle-aged with 2, and old with 3. And this actually, so our data had 3 groups with minimum of 1 and maximum of 3. And that's why the range was 1 to 3. I hope it clears your question or your confusion. Okay, so let's copy these results into our Word document and let's interpret them. It's more or less the same. Can you turn off your mic, please? And let's take the questions at the end, please. Okay, here is our second hypothesis. There are significant differences in EI across different age groups. And our age groups are young, middle aged, and old. Now let's report the results. In order to assess differences in entrepreneurial intentions across the different age groups, Kruskal Wallis age test was utilized. Age was divided into groups, namely young, middle-aged, and old. Now, the results revealed an overall partially significant. Now, why am I saying it's partially significant? Because the significance value is 0.074. Now, this is not greater than 0.10 and it's slightly over 0.05. So you should not actually reject your hypothesis in totality. So you can say, have a cautious interpretation and say it's partially significant. So Kruskal had 1L, so I'm correcting my mistake. Okay, partially significant. So you can say, or let me put it up. Okay, so I square value is 5.210. And mention the degrees of freedom here as well. Comma E is equal to, now I'm not using less than 0.00 because it's way greater than 0.000. So 0.074. Now the next part is who had the most higher entrepreneurial intentions. Mean rank analysis revealed that middle-aged employees or respondents, rather than employees, I think it should be respondents, had highest EI. So their EI was rank is equal to 235.41 in comparison to young rank equal to 208.11 and old 193, sorry, 0.37. Hence, H2 can be partially accepted. Now, how do you report the results? Let's report the results, format it. Okay. Now, just remove the borders and it will be done, so you can know now how to do it. Just give it a table 2. Let's say age. So I hope now it's clear how to use Kruskal Wallis test for comparison across multiple groups and report the results. Now, if you've got any questions, you may ask, and if not, we'll go to our last topic of regression analysis for today. Or let's take the questions right at the end after we've done our regression analysis as well. Okay, now let's do regression analysis. Now, what is regression analysis, or what is a regression? Regression is an analysis technique or analytical technique that is used to identify, evaluate, or assess that how much variation, how much change in a dependent variable is being brought up or brought about or caused by an independent or set of independent variables, maybe one or more independent variables. Now, so in order to do this in SPSS, what we do is we go for analyze, regression, and linear. So let's say I'm interested in finding out how much change in entrepreneurial intention is brought up by self-efficacy and subjective norms, or maybe internal locus of control or external locus of control. So let's do a simple linear regression in which we have only one independent variable and one dependent variable. And we are interested in finding out how much change in a particular dependent variable is being caused by one independent variable. So what we do is we go to analyze, regression, and then linear. So what you do is I'm interested in entrepreneurial intentions as my dependent variable, and my, let's say, self-efficacy as my independent variable. You do not need to do anything else, just press OK. And here you are with your results. You are presented with 4 tables, 1, 2, 3, 4. In the first table, variables entered and removed, what you see is that, okay, this is only the one model that we are testing. Variables entered. So you see your independent variable here. Variables removed, method, enter. So since we are doing simple linear regression, so there are no variables removed. If we were doing stepwise, maybe forward or backward regression, I hope if we can meet sometime soon, we can have that as well. Or if I can produce a video on the 3, I'll do that, and obviously that will be shared on the channel. Now then there is model summary. Now what this tells us that our dependent variable is EI, so correct, and our independent variable is self-efficacy, correct. What's the model summary? Now if we look into it, our model, we have got only one model. So what is R? This is the correlation between self-efficacy and entrepreneurial intention. So R is actually showing us the correlation between these 2 variables. And this shows that it's a weak correlation. The next is what we are interested in this table is R square. So if you take square of R, that is 0.237, what you get is 0.056. Now what this 0.056 means is that 5.6%, if you multiply this value by 100, you get a percentage. This is called coefficient of determination. So this shows that 5.6% change or variation in entrepreneurial intention is being brought up by self-efficacy. So 5.6% change in entrepreneurial intentions can be attributed to self-efficacy. Now, is this change significant? Is this change significant, worthwhile of studying in our research? The answer is provided by the next table. If you look at significance, it's 0.000. This shows, yes, the impact of, the influence of self-efficacy on entrepreneurial intention is significant. The next table is is not that usable in case of simple linear regression. But what if we have got multiple predictors? And in this, in the next analysis, we will be discussing this table in greater detail. For now, let's focus on these three tables. So this is how you run simple linear regression, and this is how the regression analysis can be easily interpreted. Now, how to report it? We'll do it with multiple regression. So let's run a multiple regression and see how multiple regression works. Now, multiple regression actually helps us understand what if there are more than one predictors? What if we have more than one independent variable? What if we have more than one exogenous variables? So, and we want to assess how these variables influence the dependent variable, how these variables bring a change in the dependent variable. So in order to run that regression, what we do is we go to analyze regression, and again linear, but this is multiple linear regression now. So instead of just focusing on self-efficacy, now I want to focus on subjective norms as well. Now I want to focus on, say, propensity to act as well, and then nothing else, just press OK. Now here, okay, have I done it correctly? Yes, the independent variables were correctly entered. The dependent variable is correct because the independent variables were propensity to act, self-efficacy, and subjective norms. The dependent variable is entrepreneurial intentions. The model summary. Now the correlation, the overall correlation between these variables is 0.750, and the R-square value is 0.562. So what this R-square is telling us is that 56.2% change, variation in entrepreneurial intentions can be accounted to these three variables. And overall, the impact of these three variables on entrepreneurial intentions is significant. But now let me ask this question. Are all these three variables, subjective norms, self-efficacy, and propensity to act, are all these three variables significant? So I'm asking you this question, whether propensity to act is significantly influencing, self-efficacy significantly influencing, and subjective norms significantly influencing. So now how do you answer this question? In order to answer this question, whether or not each one of them is significant or not, you go to the coefficients table. And if you look at this table, under constant, you see self-efficacy, subjective norms, and propensity to act. And their beta value, their weight of impact, their weight of influence, how much weight they carry in influencing the dependent variable. It should be over 0.20 in order for it to be significant. But sometimes, even if it's less, it's significant. In this case, if you see self-efficacy, which was previously significant in our last analysis, now it has suddenly turned into insignificant. Now this is very important thing. How come a variable which was significant individually becomes insignificant when you have got multiple regression? This is pretty normal, and this happens in, let me give you a more plain and simple example. For instance, you are pushing a car, and you are trying to push a car. If somebody weighs around 70 or 80 kg, he might be pushing a car, and it's just like slightly moving from its space or its place. Suddenly, a person comes, and he's a bodybuilder, a very Hulk-like man, and he starts to push the car. Now he will be able to take a car much further than what a 60 or a 70 kg man was going to put it or like move it. So when the Hulk man-like comes, his impact is far greater than the other person. And that person who weighed 70 or 60 kgs, his impact actually diminishes or it finishes. This happens in regression analysis as well. With the entrance, with the advent of another variable, the impact of the other variable might diminish to an extent that it becomes insignificant. And this is what happened in this case. While self-efficacy individually was significant, But with the advent of propensity and subjective norms, its influence in the organization or within the respondents becomes insignificant, or it became insignificant. How do I know it's insignificant? Because the significance value is greater than 0.05, while for the rest of them, SN and propensity to act, it was significant less than 0.05. The T value is for self-efficacy is uh, less than 1.96, while for subjective norms and propensity to act, it is greater than 1.96. Now, how do I interpret these results? I do not need my first table. I only need these three tables, and let's use these three tables to interpret our results. Let's go for regression analysis. Let's put it in a separate page. Let's propose our hypothesis. Let's say H3. There is a significant impact of self-efficacy on employee intentions. Let's put it in a single hypothesis. Propensity to act and subjective norms. So H3A is there is a significant impact of self-efficacy on entrepreneurial intentions. H3B is impact of propensity to act on entrepreneurial intentions, and H3C is significant impact of subjective norms on entrepreneurial intentions. Report the F value, where this 3 is from here the degrees of freedom, and then comma the residuals. Okay, and then what we do is we write 425 here, and the p value is 182.137, comma p value is less than 0.001. Now this one's done. Let's put it at the end so we can interpret the other table as well. What does the coefficient table tell us about the impact of each of the individual variables? So coefficient analysis revealed that, let's make the whole table visible, that SC did not significantly impact EI, and then you write T is equal to 0.076. One more thing, it's always a good idea to report your beta value, which is minus 0.003, and your P value is equal to 0.939. H3A was not supported. Let's do the next one, SN. SN had a significant impact on EI. So you report those results as well. Beta is equal to 0.395. T is equal to 11.061 and P is less than 0.001. Hence H3B was supported. Let's do the last one, which is propensity to act. It's always advisable to write the full form as I mentioned in the last analysis. So beta is 0.674, T is 13.957, and hence H3C was supported. Now let's arrange the results in a more meaningful way. Let's make it a full border, and let's remove this. We don't want this. We do not want the standardized coefficient because we normally report unstandardized value. Let's add 2 columns here, and this is slightly complex than our previous interpretations, but obviously it should be done, and your results must be well formatted, well structured, in order to have a good impression on your reviewers, on your examiners. Let's say, let's do it quickly so that we can get to Control X. Let's put it here. We do not need this B, but we need is this F and significance. Let's put it here. Or you can put it here, or there is another way. What you can do is you can put F, and you can put your significance here. You can put your R square here. So this would make more sense. Let's remove this from here, and then, sorry, your F value is 182.137 and your significance is 0.000. Your R square is 0.562, and now you can remove this, and then just click on this auto fit window, and then just format it